Welcome to another annual OSHA awareness safety training. This is electrical safety awareness. This is a general awareness training. Please give me your attention. I want to make sure that you guys understand this very well. I don't want you to be in danger either at work or at home. So there's some really good things in here that'll help you at home. It'll help you at work. Please pay attention. Give me a few minutes. We'll get through this and hopefully keep you safe. As with all of these general awareness trainings, this does not qualify you to work on electrical equipment. Only qualified electrical personnel may modify, test, or repair electrical equipment or systems. Those qualified technicians have been specifically trained and authorized to perform that type of electrical work. Once again, this is just a general awareness just to keep you safe and aware of the electrical hazards that are in your workplace. Okay, so electrical safety is golden rule number 4. Only employees who have been trained and found competent may perform electrical work. A test for DEAD must always be completed prior to working on any electrical equipment. An appropriate PPE must be worn when performing any electrical activity, and some of that PPE could be arc flash rated clothing, gloves, face shields, etc. In the event anyone ever does work on electrical circuits or equipment, the equipment must be de-energized and locked out prior to working on them. We use lockout procedures that are available to all employees, and we have approved safety procedures that must be followed to protect the safety of all affected employees in the area. All right, let's take a second and go over electricity basics. So electricity is current, and the current is a flow of energy from one place to another, and we measure that current in amperes or amps. An electrical current moves through wires, and that's what makes motors run and lights turn on. That's what makes things happen. All right, the electrical current has to travel in a closed circuit through conductors like metal, copper, and aluminum. Insulators do not allow the flow of electricity to come out or to go places we don't want it to go. Voltage is force or pressure, and it takes force or pressure to push the current through a wire. The current can harm you when it flows through your body, and that's what creates the electric shock. Is electricity dangerous? You bet it is. The longer a person is exposed to the current, the greater the risk of serious injury. You can see this graph on the right that shows the effects of electricity on the human body. Down at the bottom, it says 2 milliamps will give you a mild shock. You go up a ways, it says 100 milliamps stops your heart from beating. At 900, it starts to severely burn the human body and do serious damage. So in this graph, it looks like suffocation is possible at 30 milliamps. If you happen to be on a 40-foot extension ladder or somewhere in a dangerous area and you get a mild shock, it might scare you or jolt you enough to make you fall. So be careful around electricity. It does not take 300 milliamps to kill you. A mild shock can create some type of a dangerous situation that could do it for you. Anytime current travels through your body, you get an electrical shock. You actually become part of the circuit. So how bad it hurts you depends on where it comes in and where it goes out, how much current travels through your body, and the length of time the current is traveling through your body. You can see in the top right graph, if it comes in through your hand, goes down through your chest and out your leg, you're going to have a damage point at your hand and a damage point at your foot, but it's going to be internal damage throughout all those red lines that go through your body. All right, so anytime electricity comes into your system, it has to go out of your system. The 2 points where it comes in and goes out, you'll usually have burns or damage to the skin, and then you'll have internal skin, lung, and muscle damage where it travels through your body. Electrical burns are the most common non-fatal injury. They normally occur when you touch electrical wiring or equipment that is improperly used or maintained. Electrical burns typically occur on your hands, and they're a very serious injury that needs immediate medical attention. Our qualified electrical technicians use specific PPE to protect them from this kind of an injury. First aid, medical treatment for burns have changed over the years. The very best thing we can do now is call 911 and then use our normal first aid training to keep the person as comfortable as we can while we're waiting for the ambulance to arrive. A couple of things that we can do. We can treat the burned areas by covering the burns with a dry, sterile gauze bandage. Do not try to remove pieces of clothing. A lot of times they get stuck to the skin and you can do a lot more damage by trying to remove them. Do not use a blanket or a towel or anything that may have loose fibers to cover a burn, because those loose fibers can stick to the burned surface. Do not attempt to cool the burns with water or ice, and do not apply grease or oil to the burns. Here we see some normal types of electrical hazards that you might face at work or at home. You can have inadequate wiring. There can be exposed electrical parts, wires with bad insulation, overloaded circuits, damaged power tools and equipment. A lot of these hazards are made worse in wet conditions. Electrical injuries are commonly caused by unsafe work practices, by using unsafe equipment or installations, and from an unsafe environment. Anytime you're using any electrical equipment or electrical cords, make sure that the ground prong is not missing if it has it. It's best to only use 3-prong cords and ground fault circuit interrupting receptacles. We use fuses and circuit breakers. We guard live parts. We use extension cords the proper way, and never use any plug that is black, charred, or burnt. You can see a couple of examples in the bottom pictures here of where a ground prong is stuck, and you can see charred and black burnt areas. These are warning signs that something is getting too hot and they should not be used. So how do you avoid electrical hazards? Never work on energized equipment, live equipment. Never open an electrical panel. Make sure that we maintain a 36-inch clearance in front of all electrical panels at all times. If you're turning off a disconnect on an electrical panel, stand to the side, not directly in front of the panel. Never used a damaged outlet. Never used a damaged electrical cord. You should always inspect your cords and equipment prior to use. Never store flammable materials near electrical cabinets or equipment, and never use a portable power tool if it's damaged, hot, or sparking. Here are a few more ways to avoid electrical hazards. Do not plug too many things into one outlet. Extension cords are for temporary use only. They must have 3 prongs to ensure they're grounded correctly, and they must have a UL listing to ensure that it meets safety specs. Overloading or daisy chaining is prohibited. All right, the bottom left picture, that's overloading, and it's also daisy chaining. The bottom right is daisy chaining. If you plug an extension cord into an extension cord, that is daisy chaining, and OSHA says that is never, never allowed. If you grab a hold of an electrical cord and it is hot, find out what the problem is. Probably something is overloaded. It can be a little warm. We've all felt chargers and charging cords that get warm, but if it is hot, there's a problem. Never pull on cords to unplug them. Grab the plug and pull out on the plug. Response to someone being electrocuted is kind of a touchy subject. For years, we were all taught that you can grab something that is not electrically conductive and pry or knock the person off of what they're being electrocuted on. It's very, very dangerous to do so. You have to make sure that you never touch the person. They're probably energized, and if you touch them, you'll become part of the electrical current and be electrocuted as well. The very best thing you can do is disconnect the power source. Go over and turn it off or hit the disconnect. Do not touch the person. If you can find some type of non-conductive material like rubber, wood, or plastic that you can use to try to free the person from the electrical source, you can. It's difficult to do. The best thing you can do is get the power shut off as quickly as possible, secure the area, get someone who is first aid trained over there, make sure that you notify your supervisor immediately so we can call 911, and then begin necessary first aid and CPR if you're trained to do so. Okay, that sums up a basic general electric awareness. Please make sure that you take the quiz, fill out your name legibly so I can read it. If you have any questions, concerns, or issues, it is your responsibility to bring them up to your supervisor or to the SHE department. I want to make sure that you are completely comfortable with our electrical procedures and the things that we do to keep you safe and the responsibilities that you have to work safe. So if you have any questions or concerns, talk with your supervisor or come and talk to the SHE department. I appreciate your time and attention, and have a safe day.